Okay, so you ever wipe down a counter, it looks spotless, but you get that little feeling, is it really clean? I mean, sure, we can see the smudges, the crumbs, all that stuff. But what about the things we can't see? Well, today we're going to get into the science of that, of measuring cleanliness. It's like we're investigating an invisible world that has, frankly, huge consequences for our health.
I mean, it seems like a simple question, doesn't it? How clean is clean? But once you get down to the microscopic level, oh man, the answer is anything but simple. We just kind of trust that surfaces are safe, right? Especially in a place like a hospital. But how do they prove it? How can you possibly measure something you can't even see?
Okay, to really get a handle on the stakes here, let's look at the threat profile of a particularly nasty bug, norovirus. This thing is, wow, it's super infectious, and it is tough as nails. It can stay infectious on a surface at room temperature for up to 12 days. That's almost 2 weeks. So yeah, what you can't see can hang around for a long, long time and make you seriously, seriously sick.
And that right there brings us to our first major scene of the investigation, the incredibly high stakes world of hospital cleanliness. And this is about so much more than just making things look neat and tidy. This is literally about breaking the chain of infection.
Yeah, the science on this is crystal clear. Contaminated surfaces in hospitals are a huge reservoir for microorganisms. And these aren't just any old germs, right? These can lead to really serious healthcare-associated infections, you'll hear them called HIIs, in patients who are already at their most vulnerable. So a truly clean surface, well, it's an absolutely critical line of defense. All right, so if we need to track down these invisible threats, how has it been done in the past? What are the traditional methods for detecting this stuff? Let's get into the classic tools of the trade.
Well, the most basic method is something we all do every single day. Just looking. Visual inspection. In a professional setting, this is the bare minimum, the starting point. You look at a surface to make sure there's no visible gunk left behind. Sounds simple enough. And to be fair, it has its place. This industry guidance points out that just using your eyes can help you spot, and I love this term, gross contamination. The really obvious stuff that a random swab might actually miss. But gross contamination is really the key phrase there. It's fine for the big obvious messes, but what about that invisible world we're talking about? Yeah, for that, we've got to turn to the classic scientific method, microbial cultures. This is what's known as the gold standard. Basically, you take a swab from the surface, you wipe it on a petri dish with a bunch of nutrients, and then you wait. Any living bacteria on there will multiply and grow into these little colonies you can actually see and count. It's super accurate, but it's got one huge, huge drawback: time. So here's the dilemma, right? This is the crucial point. On one hand, you have visual inspection. It's instant, it's easy, but it's not very accurate, and frankly, it usually makes you think things are cleaner than they really are. On the other hand, you have microbial cultures. They're incredibly accurate, but you're waiting 24, even 48 hours for a result. And think about it, in a busy hospital, you just can't wait 2 days to find out if an operating room is actually safe to use. So what's the solution to this whole speed versus accuracy problem? Well, scientists went looking for a better way. And they found their inspiration in a pretty amazing and, kind of beautiful place: the glowing tail of a firefly. Okay, so this tech is called ATP bioluminescence. Here's how it works. It's designed to detect something called adenosine triphosphate, or ATP for short. Now, ATP is basically the universal energy molecule for life. It's in every living thing, and even in stuff that was living. So just think of it like a universal fingerprint for any kind of biological material. We're talking bacteria, blood, skin cells, that little bit of food residue, you name it. If it was alive, it has ATP. And here's the really cool part: the secret ingredient. The test uses an enzyme called luciferase, which is literally borrowed from fireflies. What happens is, when this luciferase enzyme bumps into any ATP, it produces light. It glows. The device then measures that light in what they call relative light units, or RLUs. It's really simple. The more light it sees, the more ATP is there, and the dirtier the surface is. It's basically a high-tech biological flashlight. And the whole process is unbelievably fast. You just swab the surface, you stick that swab into a little handheld device, and boom, within seconds, it measures the glow and spits out a number. You get a real quantifiable result right there on the spot. I mean, think about that. That's a massive, massive leap forward from waiting 2 days for a petri dish to grow.
So, problem solved, right? We've got a fast, accurate numerical test, case closed. Well, not so fast. Our investigation takes a bit of a turn here because this seemingly perfect high-tech solution, it turns out, has its own set of complications.
Yeah, even with these modern tools, the problem doesn't just go away. Look at this. A study back in 2012 at an Italian hospital found that even after the cleaning crew had done their work, a shocking 44%, nearly half of the surfaces they tested still failed to meet the microbial benchmark. So, what on earth is going on? Well, this table brilliantly illustrates one of the biggest issues. It turns out when you look across all the different studies and all the different devices on the market, there's no single standardized value for clean. It's kind of the Wild West. A review of 27 different studies found that the RLU benchmark for what's considered clean was anywhere from 100 all the way up to 1,000. That means the very same surface could pass with flying colors on one system and be considered dangerously contaminated on another. That's a huge problem.
And just to make things even more complicated, it turns out that not all surfaces are the same. That same study in Italy found that different types of surfaces hold on to gunk differently. You can see it right here in the chart. Lockers had a median contamination level of over 61 RLU, but other stuff like beds and chairs were way down at 25. So a one-size-fits-all number for clean just isn't going to work. So here's the thing you absolutely have to understand. The ATP test is a fantastic proxy for contamination, but it's not a direct measure of living germs. Remember, it detects ATP from all organic stuff. And some research suggests that only about a third of the ATP it finds on a surface is actually from living microbes. The other two-thirds is just non-microbial organic material. And that explains why the results can be so complicated and why they don't always line up perfectly with those gold standard culture tests. So after all that, we're bringing our investigation to a close. And the big conclusion is this. The answer to how clean is clean isn't just a number that pops up on a little gadget. The real answer is that truly effective cleaning, it's a whole system, a comprehensive, human-led system. Look, the technology is a powerful tool for sure, but it's only as good as the system and the people using it. Just take a look at some of these topics from a real training program for cleaning professionals. We're talking chemistry basics, different types of cleaning agents, understanding the risks of different surface materials, and even highly specialized stuff like cleaning an isolation room. This is a seriously skilled profession that requires real expertise. And this quote really brings us full circle, doesn't it? It reinforces that even the most basic method we talked about, just looking at something, is completely dependent on the person doing the looking. To do it right, you need a trained professional who gets how things like the lighting, the angle of view, the type of surface, and even their own vision can change the result. Without that training, it's just a guess. So the real solution, the true answer, isn't just one magic tool. It's a complete system. It's that combination of advanced tools like ATP monitoring, plus rigorous protocols that are based on science, and, this is the most important part, highly trained professionals who actually understand the why behind it all and know exactly how, when, and what to measure. So yeah, this technology gives us this incredible window into an invisible world. But maybe the biggest lesson is that making our environment safe isn't about finding one single magic bullet. It's about building a dedicated, smart system run by skilled people. So the next time you're in a hospital, a clinic, or heck, even a hotel room, you might look at a clean surface just a little bit differently. And you might ask yourself, what invisible story is it telling?